In Codeforces problem, NEKO's maze game, there is a grid with height 2 and width n. We start in cell 1, 1, want to reach the opposite corner to n, and we want to say if it's possible to get there without visiting forbidden cells. Every time from a cell we can move to adjacent cell, one of 4 neighboring ones, and here there is a path, so we say yes. It doesn't matter if there are multiple possibilities. Then there are Q queries. Each query, it changes the state of one cell. It makes it forbidden or it allows it again. It changes its state. After each query we should say yes or no, and the constraints are here. Both n, width of the grid, and q, the number of queries, are up to 100,000. Let's analyze some example with q queries given on the right. The first cell is 1, 4, we forbid it, and we say yes, it is possible to get from first cell to the last one, from one corner to the opposite one. Then there is cell 2, 8, still the answer is yes, 2, 2, still yes, 2, 4. Now the answer is no. Then there is 1, 6 and 1, 4 here. It changes the state of this single cell. It is allowed again, and now there is a path from 1, 1 to 2, 9. So we say again yes. So the answers were yes, 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 and then no, no, yes. And we continue. So it isn't true that it just yes for some time, then there is some first moment where we cannot reach the opposite corner, and then for the whole time it will be no. If that was the case, by the way, we could use binary search, and we could then maybe binary search over the time when there will be the first answer no. On that exact time we can run DFS from first cell and we check if the last cell is reached, and then if it was possible to reach it this way we can binary search in the further half, because the first no happened later, otherwise earlier. But binary search here doesn't make sense because we can get yes, no, again and again. So it isn't that just prefix is yes and then suffix is no. Okay, what can we do though? It might make sense for every column to keep track of the number of forbidden cells in that column. So when we make some cell forbidden, we say counter of that column plus plus, and if we make this cell allowed or empty again, we say minus minus, and whenever some column reaches count 2, we say this column is completely blocked, so we cannot go from one corner to the opposite one, from 1, 1 to n. But how to check quickly if any column is completely blocked? We shouldn't iterate over all the columns every single time, because I don't want to get complexity n times q. This would be too slow and I would get time limit exceeded. How to handle that? So some columns will become completely blocked, then maybe one of them becomes available again, then the other, and now I should say yes. How to fix that? Well, I can store one extra counter for bad columns, and I can increase it by 1 whenever some column becomes completely blocked. I could also decrease it by 1 when I need to, and then I check if there is at least one bad column just by comparing this variable with 0. Let's see pseudocode, or actually C++ code for that. Whenever I need to change the state of some cell, row call, then if it's not forbidden, then I mark it as forbidden. I increase the count of forbidden cells in this column, and if this count becomes 2, then I increase bad columns count by 1. So bad columns is a single counter, and the other two things are arrays. Else, here in this case, I should say if this was forbidden, then I mark it as forbidden equal to false, and I decrease count by 1. So here it would be instead minus minus in the opposite case, and I say if count of call from 2 it became 1, I unlocked this column, so I decrease bad columns by 1. This is an incorrect solution though, and you can take a moment to think about it. This is incorrect because the answer is no, also if there is this situation. Here, starting from the first corner, no matter what we do here, we cannot reach the opposite corner. We can only go from a cell to one of 4 adjacent cells, at most 4, and we cannot jump like this. So this is also some other bad situation, when there are two x's that touch each other by a corner. There are two questions now. Is this enough to check? So is it enough to say if there is some column that is completely blocked, so one X above the other, two forbidden cells, or two X's that touch each other by a corner? Are there some other situations when the answer will be no? And also, how will we implement this? First, let's answer the first question. Let's prove that it is in fact enough to check. So consider an empty grid where there is some X and maybe some other X's. Now, if there is nothing in adjacent cells, also by a corner, because we know if there is another X there, we cannot reach the final destination. And this is an interesting moment where I make a mistake in my proof, because two forbidden cells can be next to each other, like in the same row, and this will be all okay. You will just move over them or below them. So this is not what a proof should be. But because of my thinking here right now, it cost me wrong answer in a few minutes when I implement the solution. So it's interesting to see what a very simple mistake in your logic and thinking can cost later when implementing a problem. But if there is nothing here, and the next X can only be two cells to the right, so one of those cells or more to the right, then for sure we can move however we want through those cells. So no matter what X is here, or below, or maybe more to the right, we can still move freely here. At least every second column, it has both empty cells, and we can switch our level there. And we know that when moving more to the right, there will be at least one of those next two cells, it will be empty. And that's the full proof that we can still move to the right. So it was enough to check this for the situation with two X that are one above the other and they touch by a corner. Then how to implement this? And here let's just jump to code editor. Let's read the input first and then think about the details. Read N and Q. This is width of the grid and number of queries. Maybe I will not actually use N, but we'll see. Now repeat something Q times. If I get row and col. And now this is useful sometimes if you operate with arrays. Then by doing this, you change numbering from 1 to n into 0 through n minus 1, so indices of an array, but I think I will not actually use an array. So for the convenience, I'm going to use set. Set has a complexity of logarithm per operation, but this is fine for small constraints in this problem, 100,000. If constraints were more like 1 million, 5 million, then I would be worried about this. Here it isn't a big deal. And cells will contain currently forbidden cells. So maybe I will want to say, so if cells count row col, then this was forbidden, so make unforbidden. Otherwise the opposite, maybe this will be useful. My first idea for a solution was about columns, for every column to check if there are two forbidden cells there. Now I realize that also need that for kind of diagonals, but I don't need a separate counter for every diagonal. I just want to detect if there are two forbidden cells next to each other, and that's it. Similarly to columns, I'm going to create a counter, but neighbors, initially equal to 0, and when I detect two forbidden cells next to each other, I will increase it by 1. And at the end of a query, I will say if but neighbor at least 1, then print no, you cannot get from one corner to the other, else print yes. But what does happen here? I'm going to iterate over neighbors of a new cell, and I will do it here. I will explain why in a moment. This for loop will iterate from row -1 to row +1, and the same for columns. This for a cell, I iterate over all the 9 cells that are neighboring with me and myself. And now if R is row and C is col, then continue. I don't want to count myself. But otherwise I have a neighbor. Maybe it is outside of the grid, but then just cells will not contain it as a forbidden cell. And now if cells count row column, so if I am forbidden and I want to make it unforbidden, Then what? Actually, I don't want to 9 times do the same operation, so I will save it. So was forbidden, whether I was forbidden, is cells count of row call. This would be 1 if I was forbidden, so I'm going to say not this. And now if cells count this new cell a neighbor, then something happens. So I am row call, my neighbor is RC, and it is forbidden. If I was also forbidden, then this was a forbidden pair, but now I'm unmarking myself. So I will say but neighbors minus minus. Else but neighbor plus plus. I am becoming forbidden, and I have a forbidden neighbor. And that, I hope, should be it. The complexity will be q times here 9, at most 9 neighbors, and here just logarithmic operation to access a set. I will maybe make it slightly faster, and I will say if not in the grid, so not 1 is 1 smaller equal r and r smaller equal 2, and 1 smaller equal c and c smaller equal n, then continue. Then it doesn't make sense to check a set. Also, this set obviously can be replaced with a Boolean array 2 by n, but I don't want to bother now. During a contest, always choose the simplest possible solution. If you don't need arrays, then maybe set is more convenient and you will save like half a minute of your times. This shouldn't get time limit exceeded anyway. So let's try to submit this in Codeforces. Oh, and one more mistake here is that I never put anything into cells. So after here I consider all the neighbors, I should say cells insert a pair row call. And I don't know why I here put not. If cells contains this pair row column, cells contains forbidden cells, so obviously what's forbidden is just this. So there should be no here. I got the wrong answer, unfortunately, but I think the mistake is just here in an insert. Well, cells don't just become forbidden, because cells was my set of forbidden cells. If something is forbidden, then it becomes not forbidden, so I should sometimes erase from this set. Yeah, so let's fix that quickly. If cells count of row call, then cells erase. And otherwise what I did already, an insert. Now it should really toggle, it should make a cell forbidden or not. And now I see that actually an array, two-dimensional array, would be easier, because then I would just say is forbidden of row call becomes not is forbidden of row call. So my set wasn't a good choice, but still sometimes it would be more convenient. Like here, if I used an array, I would need to do this check, while here it was optional. Set doesn't care if it will get negative numbers. I will try again to submit this. And wrong answer again. This time I think an issue is that I just check for neighboring forbidden cells, which is not correct. If I have two forbidden cells next to each other, but in the same row, it's still okay. I can go from one corner to the opposite one, just as long as those cells are available. So I shouldn't check for forbidden cells on the same row. And I will here say, if R is equal row, then continue. Then I don't want to say that this is a forbidden pair, so I should increase or do anything with bad neighbors. Now, given that, I finally hope to get that AC. And finally accepted. I'm not going to record this video again, because what's the fun in just seeing somebody type the full correct solution at once? It's better to see somebody struggle and also see mistakes that you should avoid yourself. So my logic in explanation of how to implement that was incorrect. When I said that two x's cannot be one above the other or touching by corners, from this it isn't correct to say this means they shouldn't touch at all, because they can be in the same row. So watch out for such small mistakes in your logic. I hope you enjoyed this video and learned something new. See you next time. Bye!